Hello and welcome to Bytesized Godot, a series covering technical aspects and development tips for the Godot game engine. I'm Bryce Dixon, a professional game programmer with over a decade of game development experience ranging from solo projects to AAA studios. Today I wanted to cover string concatenation because it tends to come up for every project, but I've found people often don't know the best way to do it for each situation, or even that there are multiple ways to do it in GDScript. First off, you'll notice I'm not actually using Godot right now. This is a website I developed called GDScript Live, which allows programmers to test their code without needing to run the whole engine and with a lot less clutter on screen so we can better focus on the code. Let's start with the simplest way you can concatenate strings. Using the plus operator is pretty much the default way people join strings together, and usually there's nothing wrong with that, but we'll come back to it as we get to some more specific examples. Slightly less well known is the string format function. This also allows you to use a dictionary by specifying its keys instead of just an array by specifying indices, but I'll get back into why you might not want to do that when we look at the performance of each of our options. There's also printf style format strings using the string format operator, which is this %sign. These are pretty useful for formatting numbers specifically, but I've left a link to the documentation for it in the description since covering everything you can do probably would take a whole video on its own. I've also added a version which constructs a new array to simulate a case where the different strings aren't already in an array. One of the lesser known features of the global stir function is that it can actually take unlimited parameters and will concatenate them after converting them to strings. As of Godot 4.3, we can also use the callv method of callable on global functions, and again I've created a situation where all of our strings are already in an array and where they might not be in an array. Funny enough, this seems to be slightly broken as of current, and even on 4.4 dev 3 it is still broken for this case. But calling duplicate on the array itself before passing it to callv seems to fix that behavior. I don't think that there's currently an issue taken out on the GitHub repository, but this should be fixed at some point in the future. So this isn't necessary. Finally, at least for this video, we have the string join function. This is a pretty interesting example because the way it works is that it actually puts a copy of this operating string between the array's contents, which could be useful for formatting lists. Now, I've found in general there's no objectively best tool for this, since they all work well in their own situations and actually can be used together to solve some pretty specific situations. So in this example, I was able to use format strings, string join, and the global stir function to properly format an array of strings the same way it appears in the source code. Going back to our full list from before, I'm going to use the profiler feature of GDScript Live to compare how much time it takes for each of these options to run. Now the first thing that jumps out is just how slow string format is. Specifically, when we're specifying the index, we can actually see it's over 10 times as slow as just using the plus operator. This is also why I think using a dictionary for this might not be a great idea. To get that flexibility, you have to give up a lot of performance. Next, we can see that both the plus operator and printf format strings are basically the same. In my testing, sometimes format string is faster, sometimes plus operator is faster, but the important thing to realize from this is that format strings let us add additional content to the string we're creating basically for free in comparison to using the plus operator. If, for example, we wanted to put some spaces or commas between each pair of strings with only the plus operator, we'd actually have to do almost twice as many operations. In this case, because I'm adding brackets, it's actually more than twice as many. In this case, the extra strings are so small it doesn't actually add that much overhead, but it does add overhead. Personally, I think the plus version is much harder to read and understand when it gets this long anyway. Once again, going back to our full list, the global stir function actually comes in much slower than the other options. This was honestly a little bit surprising to me at first, but I think it's because it's the only option that can handle an unknown number of parameters. You could give it 1, 2, or 1,000 variables and it'll all handle it just fine. But using, say, the plus operator, you'd need to write a loop. That means that internally, the global stir function is pretty much doing that. This was the closest thing I could get to the built-in stir function's behavior, because GDScript currently doesn't allow us to write our own variadic functions, ones that can take a variable number of parameters. And even here, it's significantly slower than the built-in stir. The last takeaway I have from this performance graph is that there's a pretty obvious cost to constructing an array. If you look at the difference between the uses of stir, using call_v adds almost 20% to the cost, and constructing a new array adds another bump on top of that. Comparing the format string calls, constructing a new array costs almost 3 times as much as doing the actual formatting. With all this in mind, it's important to remember that usually our strings aren't already ordered properly in an array. So if we wanted to use format strings, we'd actually already be forced to construct this new array, which we can see is much slower than manually passing the variables to stir. This is ignoring the extra features of format strings, though. With all that said, I think what you should take away from this deep dive is that there tend to be many different ways to do the same thing, even for simple stuff, and that usually they each have their own situations that make the most sense for them. As always, profiling your code with a tool like this and reading documentation is the best way to avoid making a bad assumption. Thanks for watching. If you'd like to suggest a topic for a future video, please do so at the list linked in the description.